is Welsh ASMR 82. How you doing? I was thinking that I hadn't done a video on the planets for a little while. So I've dusted off my book, and today we're going to look at Mars. And I'm especially interested in Mars, not just because of its proximity to the Earth, but also because of the evidence, overwhelming evidence really, that at one point in its early life there was water. On this planet, and therefore possibly life. So let's take a little look at this planet today and learn some more about it. I wanted to start off with this section talking about the death of Mars. But I love this quote as well, saying that Olympus Mons, which is the massive volcano on Mars, makes Mount Everest, yes, it was a volcano actually, not just a mountain but a volcano, makes Mount Everest look like a sand castle. Olympus is so tall that it reaches beyond the bulk of the atmosphere. So basically, if you were to stand on the top of it, you'd technically be in outer space, not on the planet anymore, if you see what I mean. There's a picture of it here. Let me just shuffle the book for you. It's there. It's absolutely huge. Okay, let's read a little bit. Around 3.5 billion years ago, change was underway on Mars. The warmer, wetter episodes that characterized the planet for millions of years during the Noachian became less frequent, and the climate drifted imperceptibly at first towards the colder, arid state we recognize today. The water that flowed freely over the surface during the Noachian became locked away in giant reservoirs of ice. Lakes turned solid and rivers ran dry. The planet wasn't dying, far from it. The fireworks of the late heavy bombardment had faded, but rumbles from the deep maintained the violence. The shield volcanoes of Tharsis, including the mighty Olympus Mons, continued to build even as global temperatures plummeted and subsurface lava flows occasionally melted the reservoirs of ice, leading to catastrophic floods that challenge the imagination in their scale and violence. The age of Noah became the Hesperian, the age of floods, or rather less portentously, and more accurately, the age of occasional floods. The Hesperian period is named after the Hesperia Planum, a giant lava field to the northeast of the Hellas Basin in the southern highlands. The plain was resurfaced partly by the volcano at its centre, Tyrrhenus Mons, and spans almost 2 million square kilometres. First photographed by Mariner 9 in 1972, it is a relatively flat landscape with few visible rock formations. The most prominent surface features are the craters that allow us to date it. Tyrrhenus Mons is a very different volcano to Olympus Mons and the giants of Tharsis. It is much more ancient, fully formed not long after the Hellas impact 4 billion years ago, and it erupted through water or frozen ground, a process that produces large amounts of ash rather than lava, what geologists call a pyroclastic eruption. As a result of its age and composition, Tyrrhenus was more prone to erosion than the giants of Tharsis, and today stands only 1.8 kilometres above Hesperia Planum, or Planum. The Hesperian period was coincident with increased volcanic activity, particularly at Tharsis, but there is not necessarily a causal link between volcanic activity and the transition from the Noachian to the Hesperian. What is clear is that volcanism became the dominant geological force on Mars as the long-lived water cycles waned and cratered rates declined after the late heavy bombardment around 3.5 billion years ago. This is seen in both surface features and mineralogy. Hesperian surfaces are richer in sulfates rather than the clays and carbonates of the Noachian. Sulfates form in the more acidic atmospheric conditions created by the release of sulfur dioxide from volcanoes. While volcanic activity was the dominant force sculpting the smoother Hesperian landscapes, there are spectacular and notable exceptions where water reasserted its dominance, if only for a moment. Ekaskasma is an unremarkable valley today. Images taken by MRO reveal a deep, steep-sided depression lying to the north of the Mariner Valley. At 100 kilometers long, 10 kilometers wide, and between 1 and 4 kilometers deep, it would be impressive on Earth, but is dwarfed by the magnificent neighbouring valley system. 3.5 billion years ago, on frozen Hesperian Mars, however, things were different. High above, on the Tharsis Rise, lava surged upwards through the crust and met great reservoirs of ancient ice, releasing vast amounts of water that raged down from the southern highlands. The meltwater was funneled towards Eckers Chasma, where it created one of the briefest and yet most spectacular wonders of the solar system. The waters from the highlands came tumbling over the cliffs, roaring 4 kilometres down into the valley below, over the largest known waterfall in the history of the solar system. Around 350,000 cubic kilometres of water cascaded through the valley, the equivalent of a cube of 70 times 70 times 70 kilometres, in less than 2 weeks. This being Hesperian Mars, the atmosphere was not substantial enough for the liquid to persist on the surface, and the water disappeared as quickly as it came, leaving scant evidence of the great falls etched into the canyon walls. Eckers Chasma was unique in scale, but the cycle of volcanic eruption followed by fleeting catastrophic floods was repeated in many locations across the planet throughout the Hesperian. However, in the thinning atmosphere, the presence of liquid water was probably always fleeting, increasingly so as time passed. Hesperian became Amazonian around 3 billion years ago, plus or minus 500 million years or so. When a Mars expert is asked the question, when did the Amazonian begin? They will usually say, depends on who you ask. But certainly by 2 billion years ago, long before there was a complex multicellular life on Earth, Mars was pretty much indistinguishable from the planet we see today. The red planet didn't die entirely. Volcanic eruptions persisted and have occurred into the very recent past at Tharsis. There may yet be eruptions in the future, but we do know that Mars changed from a world that supported liquid water on the surface under a thick atmosphere via a period dominated by intense volcanic activity and episodic floods into a hyper-arid, frozen planet with a tenuous atmosphere more befitting its small size and place in the solar system. This drama played out very roughly during the first 1.5 billion years of its life. The challenge is to understand why. Mars is a mirror for our dreams and nightmares. To the naked eye, the planet exhibits a reddish hue, blood red in the imagination, god of war, star of judgment. Through a small telescope, it is the most Earth-like of planets, with cinnabar deserts and white polar ice caps. A world we could imagine visiting, perhaps even settling in. 19th century astronomers convinced themselves they saw plains and mountain ranges and canals delivering meltwater from high latitudes to arid equatorial cities. Some thought the Martians a peaceful civilization far in advance of our own. Others saw threat. Across the gulf of space, minds that are to our minds as ours are to those of the beasts, that perish, intellects, vast and cool and unsympathetic, regarded this earth with envious eyes, wrote H.G. Wells in his classic science fiction novel The War of the Worlds in 1897. The nature of Mars remained a mystery until well into the 20th century, because the planet is small and far away, and therefore difficult to view with ground-based telescopes. Even the Hubble Space Telescope, high above the distorting effects of Earth's atmosphere, produces images which would not at first sight have prevented Wells from publishing. With a little imagination, The ice caps, high clouds and dark regions circling the deserts could be mistaken for evidence of a water cycle, feeding the seasonal advance and retreat of vegetation. Photographs from the first flyby of Mars by NASA's Mariner 4 spacecraft on the 15th of July 1965 abruptly laid to rest the romantic notion of Mars as Earth's habitable twin or potential foe. These images revealed an arid surface, reminiscent not of our blue planet, but of our desiccated moon. Overnight, we discovered for certain that Earth is the only planet in the solar system capable of supporting complex life, and contemporary accounts of the impact of the Mariner 4 flyby suggest that this was a powerful realization. In November 1965, the Bulletin of the Atomic Scientists carries an article entitled "The Message from Mariner 4", and the message was bleak. The shock of Mariner's photographic and radiometric reports is caused not only by their denial of the terrestrial image of Mars, but by the revelation that there is no second chance, at least not in the solar system. President Lyndon B. Johnson was reported as commenting. It may just be that life as we know it, with its humanity, is more unique than many have thought. The hesitation in the first few words is revealing. Here is Mars, as a symbol of our cosmic isolation. It is as though deep, or perhaps not so deep, in the subconscious. The 1960s power brokers, all the way up to the president, suddenly understood that the Earth is far more fragile and precious than its passionate analysis of their Cold War brinkmanship might suggest. Or perhaps the perspective delivered by exploration is always shocking. Apollo 8's Earthrise, the photograph that delivered such a positive end to a troubled 1968 by setting the blue Earth against the grey moon, was 3 years away, but red Mars provided a foretaste. I'm just going to leave that in shot for you. As I finish up the video. Do you think we'll ever make it to Mars? Do you think we'll ever colonize it? Massive big thank you to my subscribers, new and old. Thank you so much for supporting the channel. And a huge, big thank you to my patrons. Thank you guys. If you're not asleep, then why don't you press like and drop me a comment? I'd love to hear from you. And I would like to say that if this is your first video on the channel, welcome. And maybe consider pressing subscribe.